Ladies and gentlemen, boys and girls, welcome to another episode on the Incredible Academics YouTube channel. And today I want to go through something. Right, there's a video that a learner of mine requested, and I've just been extremely busy and I couldn't really have time to sit and go through the topic. But today basically we're just going to be looking at finding the equation, right? So if you look at this, you can see that they're saying for each of the graphs sketched below, determine A, B, P, and whatever. Okay, so that's what we're going to be looking at. So this is basically grade 11 functions, which is still applicable in grade 12. All right, so let's get right into it. I haven't gone through these questions. I'm going through them right now as we speak, so let's hope everything goes well, because you never know when math is concerned. All right, so let's study the function. So the first one, it's gonna be the hyperbola. All right, the hyperbola. So I hope you guys are gonna be able to see this. So if we check by the hyperbola, we are given 0:1 and the asymptote at x is equals to 2. Okay, and that's good news for us if we've got the asymptote. All right, that's the vertical asymptote, x is equals to 2. The horizontal asymptote is at y is equals to 0. Okay, which is the x-axis. Okay, so we've got two things here. We've got two things. X is equal to 2, right? Also, we've got a coordinate. We're just going to call it a, this is the y-intercept, remember. This is the y-intercept, the 0:1. That's the y-intercept. So we also have the y-intercept, okay? And our y-intercept is simply 0:1. And we are given that our function is as follows: a over x minus p. And they didn't say plus q, okay? They did not say plus q. And that should already tell you that q is non-existent. Are you guys with me? Q is non-existent. So the only time q actually exists is when it's there, by the equation. So forget about q because it's 0. And now what you're going to do is you're going to substitute what you know. When the graph shifts to the right, okay, by the equation, the p is represented as a negative, right? So meaning that p is equal to positive 2, but when we indicate it there, it's going to be a minus. All right, that's just hyperbola. So now that there's p, there's q, which is a 0 over there, you're ready to find your a, okay? Because we're just going to substitute that coordinate over there. And the only thing that we're going to be left with by this equation after substituting that coordinate, it's going to be what? Just the a. Okay, so here this is x and this is y. All right, so in place of x we substitute the 0, in place of y we substitute the 1, then we solve. So let's do just that. So in place of x, okay, on the left we've got y, so we substitute 1, which is equals to a over, in place of the x we plug in the 0 from that, and then minus 2. Okay, so now we can cross multiply. Believe me, you guys, most problems that learners face, it's because of the algebra. Just solving for a, just the simple equation. Find most learners struggling. So we cross multiply. 1 times a, 1 times a is equals to 1 times minus 2. So a is just negative 2. Right? So what do we have now? We've got everything. So our function is now minus 2 over x minus 2 plus 0, which is the q. So we don't necessarily have to write the plus 0. But look at something. This is very interesting. When our a is negative, the branches of the hyperbola are always in the second and fourth quadrant. So after having found your a, you know, like you can never go wrong with the a, because the sign of the a needs to correspond with the location of the branches of your function. Does that make sense? In other words, if your a is negative, but the branches of your hyperbola are in the first and third quadrant, then you're going to have a problem. Do you understand? So you always have to ensure that the sign of the a corresponds with where your branches are located. Cool. So we're done with that. That was a pretty straightforward question. So let's see if we can find another one that might probably show us flames. Okay. Let's see. All right. So we are given an exponential function this time around. Okay. Y is equals to x to the exponent 3 to x minus p. So let's write it down. So they're saying y is equal to 3 to the x minus p plus q. And if you guys still remember, the p is not exactly an asymptote like when we're dealing with hyperbola. Do you understand? The p just represents a shift, that okay, we are now shifting the graph horizontally to the left or to the right, but doesn't really represent an asymptote. But hey, the q, on the contrary, does actually represent a what we call an asymptote. Right? In other words, your exponential function is not allowed to touch the q. It's going to approach, but it's never going to touch. All right. So now our task is to find the p and the q. But the question is, what are we given? What are we given? Okay. The problem starts right here when you can't even identify what is it that you're given. There's y is equals to -3 down there, an asymptote. Okay. So this particularly I'm finding very interesting. This is the asymptote. The problem is that some people, even when they're given things, they can't even actually see it that, hey, this is what I'm given. They don't know that the asymptote is actually the q. They don't know that. So they start saying math is difficult, whereas no. The math is not difficult. You just haven't studied, hard enough to spot these things. This -1 is to 0. You need to know what it is. Okay? So -1 is to 0 is, if it's any number is to 0, it's the x-intercept. If it's 0 is to any number, it's the y-intercept. Like, you guys need to be able to, distinguish. Y-intercept and x-intercepts, they always have a 0, as one of the, as x or y value. Okay? So, this is our x-intercept. Alright? But you can get away without you actually knowing what this point is, whether it's an x-intercept or it's a y-intercept, as long as you know how to use it. Okay, because once we have plugged this into that main function over there, we need to know what to do, with this. We need to know what to do with it. If you don't know what to do with it, well then, it's just a waste, of information. Okay, so now let's substitute the -3. So -3 is just our q. So q is equal to y is equals to -3. So now then our equation becomes y is equals to 3 to the x minus p plus, not plus, but minus the 3. All right, minus the 3. You can see that now we're only left with one thing, which is the p. And we're going to use this coordinate over there to find the p. Remember, this is the x and this is the y. Okay, so if you substitute that coordinate over there, the y is 0, the x is -1 minus p minus 3. Okay, so now we're ready to solve. So we take the -3 to the other side, and 3 is equal to 3 to the exponent -1 minus p. And it seems as if we've got a very nice problem, because we already have the same basis, you guys. So what are we gonna do? 1 is equal to -1 negative p, and someone is gonna be like, whoa, where is the 1 coming from? So we're just dropping the basis and we're creating the exponent. The exponent for 3, it's 1. Okay, so now what's the p? What's the p, you guys? So we take the minus p to the other side, it becomes positive p. We take the positive 1 to the other side, it becomes -1. So positive p is equal to -1 minus 1, which is just -2. Which is just -2. So the problem is done, you guys. So let's go on to the next problem. And the person that asked me to do this video actually wanted parabola specifically, from what I've seen. They wanted parabola, but we go in there, don't worry. So we've got another problem. Hopefully you guys can see. So we're given I'm sure you guys can identify what type of function this is. Okay, let me just write it down. Let me just write it down. All right, so what we are given here, it's y is equal to a over x minus p plus what? Plus q, okay? That's what we're given. So you can see that the a, the p, and the q are missing. Guys, most of the time your p is just there on the graph. You just need to take a look and write it down. Okay, also the q sometimes, it's just there. But the a, one thing for sure about the a, you're gonna have to find it. You're gonna have to solve for it. So yeah, they're just testing if you can actually see. So let's check. Let's check. This is the function. This is the graph. So you can see that the intersection is at 1 is to -2. So 1 is to -2. And remember, the intersection of the asymptotes of the hyperbola, it's actually at p is to q. Do you get what I'm saying? P is to q. In other words, we can immediately identify our p. P is equals to 1 and q is equals to -2. Just like that, and you collect your marks. You know what I'm saying? So it's not that complicated, you guys. So now that we've got our p and q, guys, it becomes way much easier for us to find the a. So but remember, when you substitute your p, it's going to be negative here, -1. But with the q, we're not changing any signs here. Whatever sign that's given, you know, on the graph, it's the sign that you're going to have by the equation. All right, so that's the situation, and you can see now we are left with only the a. If we can find the a, then we'll have a complete function. So let's see if we can find any coordinate that we can substitute in order for us to be able to find the what we call the a. But if you check, I don't know if you guys are going to be able to see, but if you check, we've already used this one, which is 1 is to negative 2. Okay, it's already been used, so we cannot use it again. So my advice would be, let's try and use another point if there is. And remember that that's 0 over there. So 0 is to 0 is actually one of the points that belong to this function, okay? Because this function is passing through the origin. And I think this they did on purpose so that you don't actually spot it that there's 0 is to 0 as part of the coordinates for the function. So 0 is to 0 is one of the guys that we're going to be using to find our our a. So x, y. So 0 is equal to a over 0 minus 1. All right, and then minus 2. So what do we do? 0 is equal to minus a minus 2. We take the minus a to the other side. A is just minus 2. So we've got the p, the q, and the a now. All right, now we're finally bumping into the parabola, okay? We're finally bumping into the parabola. So we're given this y is equal to a into x minus p squared plus q, okay? And once again, some of these things are already given, you know, you just need to spot them, okay? Especially the p and the q, all right? So remember, p is to q, it's just the coordinate of the turning point, all right? So let's look into the question. Here's the graph, and the turning point here, it's given, right, minus 1 and minus 2. But another thing that's given, it's 1 x-intercept. It's the x-intercept, because you can see that the graph is actually passing through the origin. Do you understand? And what is the coordinate of the origin? 0 is to 0. All right. So we've got two pieces of information. We've got the TP, which is minus 1 and minus 2. We also have where the graph passes, right? 1 x-intercept, 1 x intercept, which is at 0 is to 0. Okay, 0 is to 0. So this is on page what? This is on page 170, the Classroom Mathematics textbook, right? Grade 11. So now that we've got the two pieces of information, I'm telling you guys, we're ready to find everything, right? One coordinate, which is 0 is to 0, and the turning point. So let's get right into it. So now we're going to substitute the p and the q. We already have the p and the q because we've got the turning point. So p is equal to negative 1 and q is equal to negative 2. All right. So y is equal to a into x plus 1. Remember, when substituting the p, it changes the sign, and then minus 2. We don't do anything to the q. Whatever sign that we have, it's always going to remain the same. Okay, so you can see that here the only thing that's missing now is the a in order for us to have a complete function. So this is where this is going to come in. All right. So, and I'm pretty sure you guys, have noticed that, the way we solve these things, it's the same throughout. It's the same throughout. It doesn't matter what function you're dealing with. Okay. You just need to find that one coordinate to substitute after having found the p, the q, whatever that's already given, So 0 is equal to a minus 2. Now what is the a? We take the minus 2 to the other side. 2 is equal to what? A. And the problem is done, you guys. And obviously, our a needs to be positive. Why? Because this is a smile. So if you solved and your a is negative, but our graph is a smile, then we're going to have a problem. Okay, we're going to have a problem. All right, so another question, you guys. I'm afraid there's so many questions, but the time, not so much time. All right, so let's look at another question that we given. So we've got y is equal to ax minus p squared plus q. Okay, that's what we're given. And you can see that the a, the p, and the q are missing. But I'm telling you guys, most of the time the p and the q, they're just there looking at you, asking me to identify them. So let's go to the graph. You can see the turning point is actually given. Okay, 2 is to 0. And the turning point, it's p is to q. There's also another coordinate, which is 0 is to negative 2. And it's a special coordinate. It's the the y-intercept. All right, it's the y-intercept. So we've got two pieces of information. We've got 2 is to 0, which is the turning point. We also have 0 is to negative 2, which is the x-intercept. y-intercept. Okay. So we go, because this is the p and this is the q. So we already know that p is equal to 2 and q is equal to 0. Okay. Now y is equal to a into x minus 2 squared plus 0, because our q is just 0. And what we're going to do next is we're going to say, okay, fine. Now we're ready to substitute the y-intercept, so that we can be able to find our a. So the y-intercept says, okay, in place of x substitute 0, in place of y substitute negative 2. Okay, so negative 2 here, a in place of the x put 0 squared plus 0. And negative 2 is equal to what? What is minus 2 squared? I hope you said 4. Therefore, our a is just minus 2 divided by 4, which is equal to minus half. You see, the a is negative. That tells a story. Okay, the a is negative. In other words, we're not expecting a smile, hey? It needs to be facing down. The graph needs to be facing down. And indeed, our graph is facing down. Okay? So, let's do... honestly, I'm enjoying this. And... but my videos are capped at 30 minutes per video. So, we have run out of time. So, this time around we are given this function y is equal to a to the exponent a times b to the x. So you can see this is an exponential function. We are given the y-intercept. Okay, we're also given just an ordinary coordinate. Okay, fine. So what we're gonna do is we're gonna substitute the y-intercept first, because it's got a 0. It's easier to solve when you've got a coordinate that's got a 0. So we'll substitute that one first and then the second coordinate first. Hopefully it's gonna work. Okay, so we've got two pieces of information, which is 0 is to -1, that's the y-intercept, and -1 is to -2, which is just an ordinary coordinate. You know, my learners expect me to know everything, and honestly, sometimes I just don't know what to expect as well. I'm just, you know, seeing how things are gonna work out. You know what I'm saying? It's not like I'm an expert at the subject. It's not like I know everything. There's things that even to this day, you know, they trouble me in math. So now that we've got this, if we substitute the 0 here, I believe we're going to be able to find the a. And once we've got the a, it's going to be easier for us to find the b. Why am I saying we're going to be able to find the a? Because if you substitute 0 in place of the x, the b falls out. Okay, so that's why I'm saying we must start by substituting this one. So in place, it's this coordinate tells us that in place of the x, substitute a 0. In place of the y, substitute the -1. So -1, I'm substituted by the equation there. -1 is equal to a b times b to the exponent 0. Okay, add anything to the exponent 0 is just 1. So -1 is equal to a. So we've got our a now. So once we've got the a, we substitute it back. That y is equal to -1 times b to the x. Okay, you can see that now the missing parameter, it's just the b. So we use the other coordinate to find the b. So this tells us that in place of the x, substitute -1. In place of the y, substitute -2. So I'm going to do exactly that. -2 is equal to -1 times b to the exponent -1. Okay, so now if you check, this is the same as -2 over 1. So I'm looking to cross multiply now. If you see me writing things as fractions, -1 over b. Okay, now let's cross multiply. -2 times the b, -2 times the b. Because in order for you to cross multiply, everything needs to be in fraction. What's on the left and what's on the right. That's grade 9 work. And then b is just the 1 times -1 divided by -2, which is just what? 1 over 2. All right, so we're done with our problem, you guys. I actually wanted to do one more problem. Unfortunately, we've run out of time. But hey, thank you so much for watching the video up to this far, and I hope you do well. So that's the end of the episode, and yeah, peace out. Okay.